everyone, and welcome back to my online teaching platform. Still on application of differentiation. The first aspect of the application is the gradient of a tangent to a curve and the gradient of a normal to a curve. So in our first video or in our first lesson on the application of differentiation, we learned that when you have a curve and a line touching the curve, that line that touches the curve at just a point is termed as a tangent. And at the point where they meet, the line has the same gradient as the curve. Okay, and we also learned that the normal is perpendicular to the tangent. So if the two lines are perpendicular, it means the product of their gradient must be equal to -1, as we know in comma, or as we treated in commas. All right, so we have a problem here and we have to find a solution to it. Let us start work. Find the gradient of the tangent and the normal to the curve y is equal to 2x cubed minus 5x squared plus 3x minus 6 at the point with coordinates 1 and -6. Hence, find the equations of the tangent and the normal. All right. So we have two questions to answer. We have to first find the gradient of the tangent and the normal. So the gradient of the tangent and the normal. That's the first part. Then the second part of the question is saying that we should find the equations of the tangent and that of the normal. So we start with the gradient first. So our solution, all right, then we bring our function back. Y is equal to 2x cubed minus 5x squared plus 3x minus 6. All right. So we learned that to determine the gradient, you need to get your gradient function, which is the same as dy dx. So we have to differentiate the given function of the curve. So when we differentiate the first term, we are going to get 6x squared. The second term will give us 10x. We are just applying the power rule. So the power here multiplies everything. So the 3 will multiply these two. And you get 6. And you are going to reduce the 3 by 1. So that is why it's now 2. So you are going to apply the same rule to each of the terms. When you differentiate 3x, we are going to get the result to be 3. Anytime you differentiate the constant, the result is 0. So I make it minus 0. So our dy dx becomes 6x squared minus 10x plus 3. All right. Now, this is just the gradient function. We are to determine the gradient at the point with coordinate 1 and -6. All right. So these are the coordinates of the point. So this is the x coordinate and this is the y coordinate. All right. Now, when you take your gradient function, our dy dx, we have it to be 6x squared minus 10x plus 3. Now, our dy dx is a function of x. So we only plug in the x value. So wherever you see x in the gradient function, you plug in the x value. So it's going to be 6 multiply 1 squared. The value of the x coordinate is 1. Then we have here to minus 10, also multiplying 1 and plus 3. All right. So this will give us 1 squared 1 times 6 will give us 6. Negative 10 times 1 will give us negative 10 plus 3. So we have 6 minus 10 plus 3, and this will give us -1. So we conclude that the gradient, that is dy dx, is equal to -1. Okay, so this is the gradient of the curve at the given point. But we learned that when you have a curve, suppose you have a curve in this form, okay, and you have a tangent to the curve. and you have a tangent to the curve. Okay, so let's look at this one carefully. So we have a tangent to the curve. Okay, so you have a tangent to the curve at this particular point. So the assumption is that this is the point with coordinate 1 and -6. Okay, so this is our tangent. This line becomes our tangent. Okay, and this is our curve. So our curve y is equal to f of x. So we know the function. I just don't want to repeat it. So since they meet at this point, the gradient of the curve that we have obtained to be -1 will be the same as the gradient of the tangent. So the gradient of the tangent to the curve, gradient of the tangent will be equal to just the -1. That is this answer. All right. Now let us also look at, let me use friend. So this is the gradient that we got. Okay, these are gradients, which is -1. So the gradient of the curve is the same as the gradient of the tangent. Okay, so it's -1. All right. So let us continue. Now, we have to also find the gradient of the normal. So let us look at the gradient of the normal now to the tangent of the curve. So gradient of the normal. All right. So let us get our normal. So if you have this line, so this line, the line with color green, is what we call the normal. So this line is perpendicular to the curve. So sorry, it's perpendicular to the normal. The normal is perpendicular to the tangent of the curve. So here will be 90. So the angle between the normal and the tangent is always 90. All right. So if two lines are perpendicular, the gradient of the two lines must be equal to 1. So we can let the gradient of the normal be equal to m2. All right. So it's going to be m2 times the gradient of the tangent. So we can name that one to be 1, will be equal to -1. So we know the gradient of the normal to be m2. So we bring it back. Then the gradient of the tangent, we had it to be -1. So here will be -1, all equal to -1. Then what do we do? We make m2 the subject. So it's going to be negative m2 is equal to -1. So we just divide through by -1, -1. So it's going to be our m2 be equal to +1. So this becomes the gradient of the normal to the given curve. All right. So we are done with the first part of the question. Let us move to the second part of the question. Okay. Now the second part talks about the equation. So second part is about the equation of the tangent and the normal. So let us start with the equation of the tangent. Okay. So equation of the tangent. Now let us go back to the diagram. This particular one. Now you can see that the tangent is a straight line. Okay. So we can name it to be maybe line AB. Okay, so we are going to use the idea of finding equation of a straight line to find the equation of the tangent. All right. So we know that equation of a straight line has a formula as y minus y1 equal to m, which is the gradient of the tangent. So we can name it m1. Then multiply x minus x1. All right. Now the x1 and the y1 are the coordinate of the point or the coordinate of any point on the tangent. So they are coordinate of any point on the tangent. So we can use the point of intersection of the tangent and that of the curve to represent our x1 and that of our y1. So we have the point there to be 1, comma negative 6, because this point is also on the line. So whenever you are finding equation of a straight line, you need just a gradient and a point. If you have a gradient and a point, you can find the equation of the line. If you have 2 points on the tangent to or on the line to, you can use them to find the equation of the line. But in this case, we have a gradient of the curve being the same as the gradient of the tangent. So we are going to use that gradient. Then we pick just a point to get our equation of the tangent. So since 1 and negative 6 are the coordinate of the point where the line touches the tangent. So we can say, sorry, where the line touches the curve. So we can say that those points or those coordinates of the point are also on the line. So it's going to be, so the equation of the tangent will be y minus y1. So the y value is negative 6. All equal to the gradient of the tangent. We had it to be negative 1. Then multiplying our x minus x1. So you represent the x1 with the x coordinate of the point on the tangent, which is positive 1. So we are going to get minus 6 or negative 6 multiply negative outside. So it's going to be positive 6. All equal to, we are going to expand this bracket with negative 1. So negative 1 times x give us negative x. Negative 1 times negative 1 give us positive 1. So we are going to get it as we will transpose the x to the left hand side. So it becomes positive. So y plus x, then plus 6. Then we transpose the 1, 2. So we are going to get minus 1 equal to 0. So we are going to get it as y plus x plus 5 is equal to 0. Or you can equally write it as y plus x is equal to negative 5. All right. So this becomes the equation of the tangent. Now let us find the equation of the number. Okay, let's find the equation of the number. So equation of the number. Okay, so you could see that in the diagram, the normal tree is a straight line. So we still use the same formula, y minus y1 equal to the gradient of the normal, so which is m2, multiply x minus x1. The y1 and the x1 are the same as the coordinate of the point on the tangent, because the normal also made the tangent at that point, so that we conclude that the point is also on the normal. So for you to find any equation of a given straight line, you just need a point and a gradient. So knowing the gradient of the normal to be positive, we learned that our m2, we had it to be positive 1. So our equation, the equation of our normal becomes y minus the y1, which is negative 6 from the point, then equal to the gradient of the normal, which is 1, multiply x minus x1, which is the x coordinate of the point on the normal, which is 1. So we have y minus negative 6 give us y plus 6. Okay, all equal to, we are going to expand the bracket, so we get x minus 1. So this will give us y, then we transpose the x, so we can get it as y minus x plus 6. Then we transpose the negative 1 here to the left hand side, plus 1, all equal to 0. So we're getting y minus x plus 7, all equal to 0. So this becomes the equation of the normal to the given curve. All right. So we'll be answering more questions on how to find equation of a normal to a curve and equation of a tangent to a curve.